Welcome to lab number 9. In today's experiment, we'll be looking at losses in bends. The apparatus used in this experiment are our Armfield F1 10 pump unit, along with our Armfield F1 22 rig. The Armfield F1 22 rig sits on top of the F1 10 pump and is connected through this quick connector that supplies water to the system. The F110 pump has a volumetric tank. It comprises of a ball valve that allows collection of water in the tank. There's also a bed tapping that allows us to read volume on the sight glass, which is observed here. The F1 22 rig has a series of connections that demonstrate minor losses in flows. These connections can be observed on the chart as enlargement, contractions, long bend, short bends, elbow, and a miter. As you can observe, we have a miter bend here. Then we have an elbow. Then a short bend, a contraction, an enlargement, and a long bend. At each connection, you will observe that there's a bed tapping before and after. At each connection, we have bed tappings that give us pressure difference across each connections. There's also a pressure gauge here that tells us the pressure within the system. It can be isolated by turning this control valve to increase the pressure in the system or to decrease the pressure in the system. However, this gate valve will not be used in today's exercise. Now that the system is being purged and all the air pockets are now being removed from the manometer, we would then close the air bleeding screw. We would then adjust the manometer levels about midway on the chart so as to allow room for when flow begins. Now that the system is purged and all manometer readings are level, we can now begin the experiment. We will be running the experiment at 5 different flow rates. In each flow rate, we'll be observing the pressure difference across each bend. Our first flow rate will be done at 17 liters per minute. Second at 14, third 12, fourth 10, and finally at 8 liters per minute. Let's begin the experiment at the high flow rate of 17 liters per minute. We would verify our flow rate by releasing the ball valve to allow collection of water in the volumetric tank. We would observe the volume collected over 60 seconds. Now that we have achieved our desired flow rate of 17 liters per minute, we will read the pressure difference across each connection. So at the enlargement, it's 353 and 379. At the contraction, it's 378 and 325. At the long, it's 377 and 352. At the short, it's 324 and 388. At the elbow, we have 262 and 177. And at the miter, we have 115 and that would be 24. So what we would do next is to reduce our flow rate to 14 liters per minute, and that is done so by turning the valve on the F110 pump clockwise to reduce flow, and you can observe the manometers readings are going down. Then we would also verify our flow by adjusting our ball valve and doing our time volumetric reading with a stopwatch. After that is verified, we would proceed to take readings on the manometer. So at 14 liters per minute, we would go ahead and read at the enlargement 322 and 338. At the contraction, it's 337 and 304. At the large, it's 338 and 322. And at the short, it's 302 and 280. At the elbow, we have 262 and 209. And at the miter, it's 167 and 107. We would then adjust our flow rate down to 12 liters per minute. And as you can observe, the manometer levels are moving. Then of course, we would verify that flow rate with the volumetric tank. After that is verified, we would proceed to take readings on the manometer. So at 10 liters per minute, the large is 292 and 300. The contraction is 300 and 283. And at the long, it's 301 and 292. And at the short, it's 284 and 273. And at the elbow, it's 262 and 236. And at the miter, it's 219 and 190. Now we would proceed by reducing the flow to 10 liters per minute. And of course, we would verify the flow rate via the volumetric tank along with a stopwatch. Then we would proceed to take manometer readings. At the enlargement, it's 280 and 284. At the contraction, it's 283 and 275. And at the long, it's 285 and 280. At the short, it's 274 and 269. And at the elbow, it's 263 and 249. And at the miter, it's 239 and 224. So now we would then reduce our flow to 8 liters per minute, which is our lowest flow rate. Then we would verify our flow rate with the volumetric tank and the use of a stopwatch. At this point, we are at the lowest flow rate, so we're going to use a digital thermometer along with a mercury thermometer to take the temperature of the water at the lowest flow rate. This temperature will be used in the determination of your Reynolds number. Now let's proceed to the final flow reading. So at the lower flow rate of 8 liters per minute, the enlarged it's 272 and 274, and at the contraction it's 275 and 270, and at the long it's 276 and 274, and at the short it's 270 and 268, at the elbow it's 264 and 255, and at the mitre it's 250 and 243. So at this point we would have 5 different readings at 17, 14, 12, 10 and 8 liters per minute, and we observe the pressure difference at each connection. Again, the mitre, the elbow, short bend, the contraction, the enlargement, and the long bend. And we observe the pressure difference before and after each connection. So at this point the experiment is over. If you have any questions, feel free to contact your professor, Dr. Whitworth. Thank you.